This is 4B, recurrence relations, all about. And there's your learning intention. Can you generalize the terms of a recurrence relation? Can you write out a recurrence relation using the proper language? And can you use a graphics calculator to generate long recurrent sequences, not just the first 2 or 3 terms? In 4A, we noted that in a recurrence relation, each term is generated by doing something to the previous term. Now we want to generalize that, which means having an expression with just n instead of actual numbers. And so Tn is any term in the sequence, and the words we use are the nth term. So it's not the first, it's not the fourth, it could be any one. Once we've got that, we can then take it a bit further and say, well, we've got the nth term. What about the term before it? Well, that is n going back 1, t little n minus 1. And the term after it will be t of n plus 1. And you can go back further or forward further. That's not saying what n is, it's just saying what comes before any term and what comes after any term. So, looking at the exercise which is coming up, you'll be asked to do questions like this. Write the symbol used to represent the term before T7. Well, that's going to be T6. And in question 2, some of the terms of the sequence are there. So we're starting at 7, 9, 11, going up in 2s. So if n minus 1 is 9, you know that Tn, the next one, is going to be 11. And if Tn minus 2 is 9, the value of Tn is therefore going to be 13, 2 further forward. Leave that to you later. So that's summarizing what I just said on there. So the way to write out a recurrence relation properly is to put it down in 2 parts. First of all, you say what is the first term of the sequence, and then you say what happens to generate any particular term given the previous one. So there's one below there. T1 is 5, you then put a comma, and then you say Tn plus 1 is 2 times Tn plus 3, which is a way of saying we start with the 5, and then any term is going to be 2 times the term before it, plus another 3. In this particular example, the first few terms are 5. We know the first term is 5, and we know that any subsequent term is 2 times the previous one, so that's 2 times 5 is 10, plus 3 is 13. And then we have 2 13s, so 26 plus 3 is 29, and so on. So every recurrence relation, when you're asked to describe it as a rule, you write T1 equals something, and then Tn plus 1 equals whatever happens to Tn. Here we are, we're just given the first few terms, 400, 100, 25. Well, we're going to know that we're dividing by 4 each time, or multiplying by a quarter. T1 is 400, the first term. Tn plus 1 is Tn divided by 4. Always follow that same structure. And in question 3 on your exercise, when it comes up, don't use the calculator, just write the first 5 terms of each of these sequences, as many as it takes to get a hang of it, noting that there are some with negative numbers in there. T1 is 2. Each subsequent term is the previous term plus 3, so it'll be 2, 5, 8, and so on. I'll leave the rest to you later. That is just generating 1 or 2 terms one by one using your ordinary calculator method we learned. Here, I'm going to show you how to use the graphics calculator to generate all the numbers in the sequence and put them into a table which you can read off the calculator. So if you want to know the 100th term, when you've done that, you get to the 100th term by just scrolling down that table till you get to the 100th term. Easily done. Nothing else to do. Now, this description here is for the 84CE. I do have screenshots of what it's like on an old TI-84 if you've got one of those still. First thing you've got to do is to set yourself into what we call sequence mode. So numbers, sequences, patterns, same thing. So press the mode button, and then you'll see probably that you're on function at the moment. Go across to SEQ and select that. to get the function in. We're going to put in t1 is 5, tn plus 1 is 2 times tn plus 3, the one we've been working for already. If you have any dialog on your screen, then clear it. Make sure that y1 is empty. Texas Instruments calculators don't talk about n plus 1 depending on n. They talk about n minus 1. Texas Instruments do this slightly differently. Instead of having tn plus 1 is 2 times tn plus 3, what they do is they say tn equals 2 times tn minus 1 plus 3. So instead of having a recurrence relation written out as saying what the next term is, it says what the current term will be, which depends on the previous one to that. So on the calculator, and they call it u, and then brackets n minus 1. That means the n minus 1th term as far as graphics calculators are concerned. If you want to put u into the calculator, second function 7. If you want to put n into the calculator, you press the x, t, theta, n button, and that will put in an n for you. So if we're going to, instead of saying y equals on the graphics calculator, we're going to say u of n equals, and then you can see what we've got there is 2 times u of n minus 1 plus 3. Now you have to type a word into the calculator using those buttons I've just told you about. And then you tell it what the first term is by saying u1 equals 5. Now just try all that. Typing those things in, make sure you can do it. Ask me if you need help. So that blue line has to be filled in, and that red and the line underneath it has to be filled in. The red one will be if you want to put a second function in on the same screen, which we don't want you to do. Then, when you've got that in, press second function table, and there you have it. You've got the n column and the u of n column. So 5, 13, 29, 61 goes on. You can scroll down to get more values. Don't worry about the fact that it says T0 is an error. It's because there is no 0 position term in a graphics calculator. It's not really an error, it's just that there is no such value, as far as TI is concerned anyway. And down the bottom, it says there, don't forget to set your mode back to function mode when you finish with sequences. Otherwise you'll start to do sequences and start to do something other than sequences and they won't work. This is the screenshots if you've got an old TI-84, still set mode and then SEQ like that, but it's a bit of a different screen. And otherwise it's pretty much the same. So the rule goes into UN and the initial value goes into U of N min, minimum value for N, I suppose that means. And second function table to see the values. And there are some more questions on the exercise. Question 4 and 5 ask you to do what I've just showed you, but on a graphics calculator. Just make sure you can put them in. And that's it. If you've got all that, you can now generalize the terms of a recurrence relation and you can write one out. You can generate long recurrence sequences on a graphics calculator. So over to you, exercise 4b, page 106.